Last but not least, we need to connect this material back to what we know about conic sections, right? So the deal is, if I write this equation using rectangular coordinates, I should get something recognizable, right? So that's what we're going to focus on here. Now, this is the same exact equation we just worked with in the last problem, which we know is a hyperbola. So we know that we should be looking out for certain things. And the main thing is, with a hyperbola, your square terms are going to have different signs for coefficients, okay? So there's going to be an x squared, there's going to be a y squared, they're going to have opposite signs. So we'll strive for that. We'll see what we can make happen here. So the first thing I'm going to do, I'm going to multiply both sides by 2 plus 3 sine theta. So that's going to give me 2r plus 3r sine theta equals 6. Well, okay, so this is a little bit awkward because this is already set up the way I want it, but that's going to be a little strange. Here's what I'm going to do. I'm going to make the substitutions as I know them right now. So r is the square root of x squared plus y squared. R sine theta is just y. Now, as far as writing the rectangular version, remember that it's always best if we're going to have to square both sides. I'm going to isolate the square root to one side of the equation. So it's going to be 6 minus 3y on the right. So at this point, we'll square both sides. So if I square the square root, well, I have 2 squared, which is 4, and I square the square root, which is x squared plus y squared. On the right, we have, let's see, 36 minus, twice 6 and 3 is another 36, and that's 9y squared. So we have officially 4x squared plus 4y squared equals 36 minus 36y plus 9y squared. And then to make it official, we'll just bring everything to one side. I'm going to bring all the terms over here. So 4x squared, now we have 4y squared minus 9y squared, so that's minus 5y squared. That's good news. And then plus 36y minus 36 equals 0. And that is the rectangular equation of the conic that we just worked with there. So we could take that, complete the square, find all of our coefficients, blah, 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 find the vertices, find the foci, etc. You would notice that one of the foci is at 0, 0, and you would notice that the vertices should line up to what we got up here. Oh, I erased some of it to make room. But I believe one of them was at like 0, 6 or something like that. So we should notice that. And yeah, so that's where we are. So there's a rectangular equation. At least we got an expected result. Thank you for watching, and I hope you have a better understanding of conics and polar coordinates now. Thanks.